Hello, Honors Geometry. This is 10.1 samples that we're going to go through all about circles. So we'll start with our sample 1 where we are presented with a circle and two tangent lines meeting at an external point outside of the circle, and we have labels on the length of those tangent lines. So we're going to know that they are in fact congruent because those are tangent lines meeting at a point external to the circle. So we're going to be able to equate x squared minus 7 equal to x minus 1 quantity squared. Then we'll step through the process of solving for x, which is our goal here. So we have x squared minus 7 equals x squared minus 2x plus 1. We work that out by FOIL. Then we can subtract x squared from both sides of the equation and arrive at negative 7 is equal to negative 2x plus 1. Our next step then will be subtracting 1 on both sides so that we have negative 1 equals negative 2x. Finally, dividing by negative 2 on both sides will provide us with the value of x as 4. And that completes sample 1. Moving on to sample 2. Sample 2 is asking us to determine whether or not the line segment AB is in fact tangent to circle C. If it is tangent, that means that angle CAB will be a right angle, and that means that we would have a right triangle ABC if in fact AB is tangent to circle C. So we can ask the question, is a squared plus 15 squared equal to 8 plus 9 quantity squared? That's plugging the legs squared and added and setting that equal to possibly the hypotenuse squared. Now notice that we have 8 plus 9 for our hypotenuse, the side of the triangle that is opposite the possible right angle. We know that's 8 plus 9 because the radius of the circle is 8. And so we need to put the radius of the circle 8 together with 9 to find the entire length of that hypotenuse. When we simplify that equation, we'll end up with is 64 plus 225 equal to 17 squared. 64 plus 225 is 289, so we're asking is 289 equal to 17 squared, which is also 289. So yes, AB would be tangent to circle C. Finally, for our last sample, sample 3, we are asking the question, what is the length of the radius R? Knowing that Q is in fact a point of tangency. Because Q is a point of tangency, that guarantees that RQ and CQ are in fact perpendicular to each other, forming a right angle. And so RQC is a right angle, and so then we have a right triangle that we can work with. And we can use the Pythagorean theorem to sum up the square of the legs and set that equal to the hypotenuse squared. So we have r squared plus 12 squared, and we're asking is that equal to the hypotenuse r plus 8 quantity squared. Our next step then is doing some simplifying. So we have r squared plus 144 for our 12 squared, and that is equal to, and then again, we're going to use FOIL here, and we're going to multiply r plus 8 times r plus 8 and arrive at r squared plus 16r plus 64. Simplifying further, we're going to subtract 64 on both sides. We'll arrive at 80 is equal to 16r. Dividing both sides by 16 will mean that r is equal to 5, and that completes sample 3 because our goal was to find out the length of the radius, which we now know is 5. That completes our samples for 10.1. It's time to make sure you have the sample notes on your lesson paperwork, review it, and then go ahead and set about working on the quiz. And I'll see you next in guided practice.